All right, Mr. Ahmed here for 2.6. Goal for today is going to be using some geometric relationships. All of these relationships can be proven. I'm not going to step through all of these proofs. I'll talk about how they're very straightforward and can be proven. The first one is just defining that a theorem is a statement that can be proven. So the most common theorem you've probably heard of is Pythagorean's theorem. It's something that's not obvious. It has to actually be proven true for all cases. So the first one we're going to talk about is a little bit obvious, and that's right angles. And theorem 2.3 means chapter 2, theorem 3. Preferably don't title it by that when you're doing your homework. Actually say the right angles congruence theorem. The answer key a lot of times is just going to say theorem 2.3, but we don't know what that is. All right, no one remembers 2.3 is this, but if you say right angles congruent, guess what? I know what that means. So our very first theorem just states that all right angles are congruent, which makes sense. If I have a right angle here, it is 90 degrees. If I have a different right angle over here, it's also 90 degrees. So since they're both 90 degrees, they have the same measure, thus they would be congruent. It would be a very short proof. The next one's the congruent supplements theorem. Now this one is just a shortcut that can be used in a lot of times, and really what it's saying is if I have two angles, angle 1 and angle 3, that are both supplementary to angle 2, that would mean that angle 1 and angle 3 would have to be congruent because they're supplementary to the same thing. So let's just say, for instance, that this is 150 degrees. If angle 2 were 150 degrees, that would mean it's supplementary with angle 1, so 1 would have to be 30. 3 would also have to be 30 because it's supplementary with angle 2 as well. So that's kind of what we got going on there. It's a nice little shortcut. If you see it, you can use it. Same type of thing with the congruent complements theorem. In this case, angle 4 and 5 are both complementary to the same angle. So if they're both complementary to the same angle, then they would have to be congruent. So in this diagram, 4 and 5 are complementary. 6 and 5 are complementary. Thus, 4 would have to be congruent to 6. And the linear pair postulate, this one's vital. Imperative, you're going to see it all the time. If you see a straight line, you can assume it's a straight line, and the two angles that make the line add up to 180 degrees. And finally, vertical angles. Vertical angles make the x. It's two lines that intersect, and the vertical angles are congruent. So angle 1 is congruent to angle 3, 2 is congruent to 4. You can assume that in a diagram when you see it. So for the rest of the year, we'll be looking for lines. If you see a line, 180. Vertical angles, congruent. We got to see that in a diagram and use it. So we're going to put that to play here a little bit. And it says identify all the pairs of congruent angles in the diagram. And how do I know they're congruent? Boy, there's going to be quite a few. So in the diagram, I know angle 1 is congruent to 4 because they're vertical angles. All right, I would also know that 5 is congruent to 2. Now, 2 is 57, so 5 also has to be 57. Okay, let's see here. What else do I know? I know angle 6 is congruent to angle 3, which is also 57 degrees. So that would mean angles 5, 6, 2, and 3 all have to be congruent. So I'm going to keep going here. So angle 5 was congruent to 2. Angle 2 is congruent to angle 6. And that's also congruent to angle 3. So all 4 of these have to be 57. Now I could figure out what angle 4 is because all 3 of these have to add up to 180. So I'm going to figure out what angle 4 is. 180 minus 57 would be 66. So this one's 66, this one's also 66 because they're vertical angles, so they would not be congruent to any of the others. All right, find the value of x. So in the diagram, I see I have a pair of vertical angles. 148 has to equal 3x plus 1. And then we can solve. 142 equals 3x. 142 divided by 3 is 47. I made a mistake. Sorry, 148. I don't know what I was doing. So it was a 148 minus 1. That gives me 147. I didn't think my answer made sense, so I did a double check. 147 divided by 3 is 49. And we got it. Next, find the value of q. So looking at the diagram, I see a straight line. I can assume it's a straight line, so these two angles have to add up to 180 degrees. So 180 equals 7q minus 46 plus 3q plus 6. And then we will solve. Combine like terms. 10q. 46 and 6. Negative 46 plus 6 gets me negative 40. Let's add our 40 to both sides, and I have 220 equals 10q. And when we divide, q is equal to 22. So main thing here, two angles, they made a line. They have to add up to 180. And finally, our x again. Vertical angles are congruent. Putting a tick mark in, so 8x plus 7 has to equal 9x minus 4. And then we could solve that. So I will subtract 8x and get 7 equals x minus 4. Got our 4, x is equal to 11. And for the y's, let's see here. These two also are vertical angles, so they're congruent. So 5y equals 7y minus 34. Subtract our 7y, negative 2y equals negative 34. And 34 divided by 2, negative divided by a negative, gets me a positive 17. And that's it for chapter 2. Have a good one.